This week in Visaya Weekly, I send a package to our friends in Sweden. We learn about steam. The great people of Sweden, the same people of Vikings, ABBA and modern furniture, are importing our waste and producing energy out of it. This is why I'm sitting on my longfield and working on my Falkhoden to send to our Scandinavian friends this package with my contribution, 1 kilogram of waste. The content of energy that any substance has is measured in watts per hour, but there's another standard measurement called TOE, tons of oil equivalent. 1 TOE is equal to 11.63 megawatts hour. That means that 1 kilogram of oil has 11.63 kilowatts hour of energy. The average amount of energy needed to heat a modern house in Northern Europe is of around 15,000 kilowatts hour. So in order to heat my house for a year, I will need 1.3 tons or 1,300 kilograms of oil. 1 ton of waste has an energy content of around 2.2 megawatts hour. The package I have here has then 2.2 kilowatts of energy. I will need around 6,000 of these packages to heat my house for 1 year. Well, actually these numbers are not correct. Since the Swedish government has really strict environmental policies, around 50% of the waste is sorted and recycled. Only 50% of this waste will be used to produce heat and power. As a result, I will need 12,000 of these packages to heat my house for a year. So how do the Swedish people exactly extract the energy from waste and convert it into something useful? Using incinerators, waste gets burned in order to produce steam. When heat is applied to water, this increases its temperature till around 100 degrees Celsius. At this temperature, there's a phase change, and water transforms into its gaseous phase, vapor. But what happens if I keep heating up this gas? Then this steam becomes what is called superheated steam.
What we're trying to do is we're trying to get to the steam hotter and hotter beyond 212 degrees Fahrenheit because we want it superheated. And how we'll know that it's superheated is that the steam will no longer be visible. You see how it's
really
getting clearer and clearer?
It is.
And now this is the dangerous part, is because now you can't really see it. But it's actually the absolute most dangerous portion. Get right in there, Chris. Don't be shy.
I'll get after it, buddy.
I need you to help me here. I need you to help me. We got to superheat it. All right, I'd say do you see it, but you can't see it, right?
I don't, no.
You don't see it. So now we know that we're pretty hot. So if you want to put yours down, go ahead and turn your torch off. I'm going to continue to torch. And go ahead and try a different match, one that we haven't moistened.
Okay.
I'm going to keep it heated. Yep, and put it right up next to it.
Superheated steam stores energy, so much energy that it's able to burn paper. This energy is the one used in Sweden to generate power and heat to the city. Steam is conducted into turbines. Steam turbines are able to produce power enough to provide electricity for 260,000 households. After the steam has gone through the turbine, steam still has a lot of energy. So this steam is transported using pipes into heat exchangers used to heat up the water using the heating systems in our homes and offices. So here's a clip of the waste to energy plant and of the turbine. But wait a minute, did you see all the instruments that were installed on the turbine? No? Let's give it another shot. So here they are. As you have seen, there are more than 30 pressure, temperature and flow transmitters around the turbine. This is because only by using process automation and instrumentation, these kind of solutions are possible. The amount of energy and quality of steam is related to the temperature and pressure of the system at any given time. Vortex flowmeters are able to measure the flow of multi-phase steam, and actually by using temperature and pressure are able to measure the quality of the steam in the pipeline. If the quality of the steam goes under 80%, an alarm of the instrument turns on, allowing operators to implement some corrective actions. So why is it so important to care about quality of steam? If you use wet steam, with around 85% of quality, this means if you spend 100 euros worth of waste in order to heat your steam, you will only get back 85 euros worth of energy. That's why it's so important to use the proper instrumentation on your processes. This is the only way you can guarantee the quality and efficiency of your plant. There are hundreds of applications and millions of instruments used every day. Let me know on the comments below if you want to learn more about any application. Here's a bonus question. Here's a clip of a furnace that goes at 900 degrees Celsius. How do they measure the temperature inside the furnace? Leave your thoughts on the comment section below and I will give you the answer next week. Thank you for watching this video. If you like it, give it a thumbs up. If you want to learn more about process automation or instrumentation, make sure to visit our website. If you want to see more videos like this one, subscribe to our channel and please follow me on all the social media. Till next time.